The cosine rule helps us solve triangles in two main scenarios. First, when we know two sides and the included angle, also known as SAS. Second, when we know all three sides, or SSS. In our first scenario, we know two sides and the included angle, or SAS. Let's say we know sides A and B and the angle C between them. To find the unknown side C, we use the cosine rule formula directly. Let's work through an example. Given sides A equals 8 units, B equals 6 units, and angle C equals 60 degrees, we can calculate side C. Substituting into our formula, c squared equals 8 squared plus 6 squared minus 2 times 8 times 6 times cosine of 60 degrees. Simplifying, we get c squared equals 64 plus 36 minus 96 times 0.5, since cosine of 60 degrees is 0.5. This gives us c squared equals 100 minus 48, which equals 52. Taking the square root, we find that side C equals approximately 7.21 units. In our second scenario, we know all three sides of the triangle, or SSS. If we know sides A, B, and C, we can find any of the angles. To find angle C, we rearrange the cosine rule to isolate the cosine term. Let's work through another example. Given sides A equals 7, B equals 8, and C equals 9, we can calculate angle C. Substituting into our formula, cosine of C equals 7 squared plus 8 squared minus 9 squared, all divided by 2 times 7 times 8. Simplifying, we get cosine of C equals 49 plus 64 minus 81 divided by 112. This equals 32 divided by 112, which is approximately 0.286. Taking the inverse cosine, we find that angle C is approximately 73.4 degrees. The cosine rule can be written in three different forms, depending on which side or angle we need to find. To find side C, we use the formula c squared equals a squared plus b squared minus 2ab times cosine of C. Similarly, for side A, we have a squared equals b squared plus c squared minus 2bc times cosine of A. And for side B, b squared equals a squared plus c squared minus 2ac times cosine of B. Choose the appropriate form based on which angle or side you need to find in your specific problem.